Now let's understand the closures with the help of execution context, environment records, and the memories like all stacks and heaps. So here, this is our the same function as we are using earlier. So here, this is our global execution context. You can imagine it in this manner. So this includes all of the stuffs which is globally available. So that is our global execution context. Similarly, we have execution context of the function A. In the curly braces of the function A, we have y, b, return. So this is a part of the execution context of the function A. Similarly, execution context of the function B includes z output and like this. So here we can see the environment records of these execution contexts. So for the global execution context, we have the global environment record, which includes all the global variables and the functions, as you can see. X, A, bref, output and function log. Similarly, X, A, bref, output function log. Similarly, you can also imagine for the execution context of A, we have environment record of A also, which includes Y and B. As you can see, Y and B generally. This function Y and B, that is part of the environment record of the function A. Similarly, we have B. Inside that we have Z and output. So this is now you can see function B is nested inside the execution context or the in the environment record of the function A. Similarly, you can see is nested inside the global environment record. This is how you can visualize the execution context. Now let's understand the execution context first.
So execution context includes three components. First is variable environment, second is lexical environment, and the this binding, this keyword binding. So these are the components generally execution context includes. So execution context is an abstract concept used by the ECMAScript specification to track the runtime evolution of the code generally in the call stack. So let's see, variable environment means all the variable, declared variables, let, const, bindings, and specific variables all. Now the main thing, lexical environment that we need to understand. So it does two things. So what it does, it keeps track of the association of the variables and the functions in the current scope as well as in the outer scope. It keeps the references of the scope change generally. So what it does, it maintains the relationship between the variables and the functions in the current scope as well as in the outer scopes. Relationship means which function using which variable, where the variable or the function physically written in the code, like the location generally. So all of this stuff is done through the lexical environment. Finally, we have this binding holds the value of this keyword based on the context in which the function is called. Now we have understood the execution context and all of its component. Now let's visualize this closer with the help of the execution context. So this is our global execution context. This is same. It includes all of this stuff. It has environment records. We don't have lexical environment in the global execution context because this is our last scope. There is no outer scope of the global scope, global execution context generally. That's why there is no reference inside this. Now we have execution context of the function A. Similarly, we have execution context of the function B. Now let's see it. Inside the global execution context, we are calling function A. Here we are calling function A. Inside the when we are calling the function A, then it creates its own execution context that has its environment records and a lexical environment. Similarly, when I'm calling the function B inside the execution context of the function A, it creates own execution context which has its environment records and the lexical environment. So now let's see what happens. So the lexical environment in the function A, it keeps track of the environment record of the global execution context. So it saves the reference, generally reference of the environment record of the global execution context. Similarly, here you can see lexical environment of the function B saves the reference of the environment record of the function A generally. That is how it keeps track of the references. Now we will understand how a function B is able to call the x and y, how the function B is able to use x and y even though outer function A has returned it, even though it lost its environment record and the execution context from the call stack. Then how we are even able to access the x and y. Now we will understand it with the help of the call stack and the heap. That will bring the more clarity. First, let's put some light on the stack and the heap. So stack is responsible for storing primitive data types, function calls, small data generally. It is a short memory. It pushes the items and it's pop the item when its execution is done. On the other hand, heap is a long live memory. It stores all the non-primitive data types like objects, arrays, set, and map, and all of the stuff generally, or the large data set data generally. Let's see some of the functionalities of the stack here. So stack keeps track of the function call management generally. Stack is used for function call management. Yeah, as we can see. Similarly, we can see here when a function is invoked, its execution context like parameters, local variables is created and stored on the stack temporarily until the execution is done. Now, the third property, when the function completes its execution context is removed from the stack and its local variables would typically be discarded. This is the general approach. All the environment records, variables, and all everything will be discarded when its execution is done. But this is not happening with the in the closures, because when the outer function returned, its execution is finished, but still we are able to access those environment records. We will understand it with the help of the heap. So let's see here what heap does. Heap is used for longer lived memory, yeah, as we have seen. Similarly, second point, variables that needs to persist beyond a single function call, such as variables captured by a closure, are moved to the heap. This is very important point. Now let me repeat it once again. Variables that needs to persist beyond a single function call, such as variables, such variables are captured by a closure and are moved to the heap. We will understand it with the visualization. So now third point, JavaScript engine manages this allocation and ensures that memory is not garbage collected as long as it is still referenced. Now here JavaScript engine moves your environment records from call stack to the heap when there is a reference pending in any execution context. That is what JavaScript engine does. And the garbage collection algorithm generally mark and sweep. It doesn't claim that space. Now let's see with the visualizations. Now let's understand the execution flow of the closure function with the help of the call stack. So at first, in the call stack, a global execution context would be pushed. That global execution context has all of the stuffs which is declared globally, all of the environment records and functions and variables. Then when it comes to the call function a call, then you can see whenever a function is called, then a new execution context will be created immediately, and that will be pushed in the call stack. That is how execution context of the function a is pushed. But as you can see, when I'm going inside the function a, as you can see, it is returning a reference of the function b. Whenever a function is returned, its execution context will be popped out from the call stack immediately. But as you can see in the next line, I'm calling the bref. I'm calling a function. In that case, a new execution context will be created for the function b. Then a new execution context will be pushed in the call stack, as you can see. When the execution finishes for the execution context b, then it will be popped out from the call stack immediately. Similarly, in the end, global execution context will be popped out from the call stack. This is how the execution happens. Now let's see it with the real scenario. So here we can see this is our call stack, this is our heap, And this is our garbage collector mark and sweep algorithm. Here we have our code. So what will happen at first? Global execution context will be pushed in the call stack. It has its all environment records and variables. When it comes to the execution or the function call in the global execution context, so for a new execution context will be pushed in the call stack. As we have seen earlier, execution context of the function A has environment records and the lexical environment. So here function A has access to the global access because it keeps the reference of its environment record of the global execution context. Similarly, when the function A returned the reference of the function B, in that case, it will be popped out from the call stack. But here, as you can see, this is the environment record that will also be destroyed with whenever the execution done. So that will be destroyed completely. So what happens? That environment record from the function A will be pushed in the heap generally. It will be saved in the heap. That is done by the JavaScript engine actually. Garbage collector algorithm keeps track of the references in the call stack and the heap. If any of the execution context have the reference of any environment records, that it won't claim that space. JavaScript engine moved the environment record of the function A into the heap. Then the execution of the function bref comes, then it puts the new execution context. It keeps track of the reference of the environment record that is now in the heap. That's why the closures are able to access the variables which is in the outer functions scope generally, because their environment records are saved in the heap. That is all done by the JavaScript engine. When the execution of the function B finishes, then it will be popped out from the call stack and its reference of the environment record will be lost. In that case, what will happen? That space don't have any references, means there is no execution context who is keeping track of this space now. So what will happen? The garbage collector mark and sweep algorithm will destroy it and claim the space immediately. Finally, we have global execution context. Now, in the end, it will print the output and its global execution context will also be popped out from the call stack. So this is how the execution flow happens with the help of the call stack and the heap. Finally, let's understand the applications of the closure. So first, closure are the foundation of many patterns in JavaScript such as encapsulations, currying, memoization, and the callbacks. Let's see one by one. Encapsulation hiding implementation details. Yes, closures does so. Callbacks functions retaining access to data after being passed around. Yeah, after the return, we are still able to access the outer function lexical environment. Yeah. Currying is a functional technique that partially apply arguments and can do the computations generally. Yeah. Memoization is storing results of expensive computations. We have seen closures allow state persistence and private variables, making JavaScript more powerful and expressive. Yeah. So this is how you can use the closures in your projects like React, React Native, Node.js, and all of the JavaScript framework generally. If you find this video is useful for you, or it, so you can comment, like, or subscribe. Yeah, that.